So let's take a look at, we'll do a little bit of everything from the review. So let's look at number 1. So to figure out what quadrant does theta lie in, so we have to know are all students take calculus. So that tells us which quadrant each trig sign is positive. So all students take calculus. It says cosine is less than 0, meaning that it's negative. Which two quadrants can I cross out, knowing that cosine is negative? 1 and 4. Perfect. It's not going to be in the all positive one, and it's not going to be in the cosine positive one. And then cosecant is greater than 0. So cosecant goes with sine. Greater than 0 means that it is positive. So which quadrant are we in? The second quadrant. Perfect. So we are in quadrant 2. Let's do number 2. Actually, let's do 3. So all students take calculus. Sine is less than 0, meaning sine is negative. Which two quadrants can we cross out? A and S. Awesome. 1 and 2. Because it's not going to be in the all positive and it's not going to be in sine positive. Secant is greater than 0. Which trig function does secant go with? Cosine. So cosine is positive. So which quadrant would we be in? Which one? 4. Awesome. So we'd be in quadrant 4. Or it'd be written in Roman numerals as IV. Quadrant 4. These are the same. All right, let's look at number 4. So we're going to find all 6 trig functions, exact answers only. So first, we want to figure out what quadrant we're in, and we would need to find our x, y, and r. So it doesn't really matter what we do first, but let's figure out what quadrant we're in. All students take calculus. So sine, is sine positive or negative? Negative. It tells us sine is negative 4 over 9. So sine is negative. Which two quadrants can I eliminate? The first and the second, because it's not going to be in the all positive. It's not going to be in sine positive because it's negative. And then tangent is less than 0. So tangent is negative. So which quadrant are we in? Quadrant 4. So the only things that are positive are cosine and its reciprocal, cosecant. Nope, sorry, secant is its reciprocal, cosine and secant. So let's find our remaining trig functions. Thank you. So sine is what over what? Y over r, perfect. What do you think the negative goes with, the y or the r? How do you know that it goes with the y? R is always positive, perfect. R is always positive, so r is going to be positive 9. Y is negative 4. How would we find x? Pythagorean theorem. X squared plus y squared equals r squared. So x squared plus negative 4 squared is equal to 9 squared. So x squared plus 16 equals 81. Subtract 16 on both sides. X squared equals, be careful with the math. You do not get a calculator. Just be careful with doing the math. Here, this would equal 65. Yep. Take the square root. So x equals the square root of 65. Can I simplify the square root of 65? No. Our two factors are 5 and 13. Can't break it down anymore. So just the square root of 65 would be our x. I'm going to write that my list up here. So now I have my x, y, and r. Let's find our 6 trig functions. So sine was given. That's negative 4 over 9. Cosine is what over what? X over r, so square root 65 over 9. Tangent is what over what? Y over x. So y over x would be negative 4 over square root 65. Can I leave a square root in the denominator? No, we have to rationalize. So we get negative square root 65 over 60, negative 4 square root 65 over 65. Can we simplify any more? No. So that would be our tangent. Let's find our reciprocal function. So cosecant goes with sine. Our reciprocal would be negative 9 over 4. Secant goes with cosine. So that would be 9 over square root 65. We'd have to rationalize. So we get 9 square root 65 over 65. And then cotangent goes with tangent. So here we would get square root 65 over negative 4. So these are 6 trig functions. On the quiz, it may just ask for 1 or 2 or 3. So just pay attention for what it's asking for. Also, let's just double check our signs. We said that we're in quadrant 4, so only cosine and secant are going to be positive. The rest of them are going to be negative. All right, so cosine and secant are the only positive ones. So sine is negative, tangent's negative, cosecant's negative, and cotangent's negative. Secant and cosine are positive. So you can always just check your work at the end. Make sure you're in the right quadrant. Make sure your signs are correct. Any questions here? All right, for number 6, we want to find our reference angle. Reference angles always have to be 2 things. What are those 2 things? Acute and positive. So our reference angles always have to be acute and positive. If they're not acute and if they're not positive, you did something wrong. And then depending on what quadrant we're in, we use a different formula. So if we're in quadrant 1, whatever our reference angle is our theta, as long as it's acute and positive. If we're in quadrant 2, we do 180 minus theta to find our reference angle. Quadrant 3, we do theta minus 180. And quadrant 4, 360 minus theta. If you get something that is not acute and not positive, you probably use the wrong formula. What quadrant is 123 degrees in? Quadrant 2. So since we're in quadrant 2, we're going to use 180 minus theta. So 180 minus 123. What do we get? $57 degrees. That would be our reference angle. 57 is acute and positive, so we're good. Let's do number 9. So here it's a little bit harder to tell where our radian falls. So for negative 7 pi over 3, what would we need to do first? Convert. Let's convert it to degrees so we know what quadrant we're in. So we're going to multiply by 180 over pi. Pi's cancel. 3 goes into 180 60 times. So 60 times negative 7 would be what? What's 6 times 7? So negative 420. Now negative 420, since it's negative, it's not going to work for one of our little formulas that we have here. So let's find the positive coterminal version of this. How would we find the positive coterminal version? Add 360. So when we add 360, we get negative 80. No, negative 60. We can add 360 again. Again, we're looking for the positive coterminal angle of it just so we can plug it into one of our formulas. So when we add 360 again, we get 300. So now let's find what quadrant 300 degrees falls in. What quadrant would 300 degrees be in? quadrant 4. So I'm going to use 360 minus 300, and we get 60 degrees. But my question gave me radians, so my answer has to be in radians. So how would I change the reference angle of 60 degrees to radians? Multiply by pi over 180. So we would get pi over 3. So that would be our reference angle. Let's do 10. So we're going to multiply by 180 over pi to convert it to find out what quadrant we're in, so we know what formula we can use. 5 goes into 180 how many times? 36. So we have 36 times 12. We can write that out. 36 times 12. 2 times 6 would be 12. 2 times 3 is 6, plus 1 would be 7. Drop down to 0. 1 times 6 is 6. 1 times 3 is 3. So 432. So we're talking about 432 degrees. That's more than one time around our unit circle, so it's not going to work for one of our formulas. How would we find a coterminal angle to that? Subtract 360. So when we subtract 360, we get 72 degrees. What quadrant is 72 degrees in? Quadrant 1. Perfect. So whatever our theta is, that's going to be the same as our reference angle. So we don't even have to plug it into a formula. 72 degrees is our reference angle, but our reference angle has to be a smaller version of our angle. So if our angle was in radians, our reference angle also has to be in radians. So we're going to multiply it by pi over 180 to convert it back. What goes into both 72 and 180? $36. 36 goes into 72 twice, and 36 goes into 180 5 times. So we're left with 2 pi over 5. So that would be our reference angle. All right, for 11, 12, and 13, we want to use the reference angles to evaluate the 6 trig functions. On the quiz, we're going to give you the first quadrant of the unit circle. So you don't get the whole unit circle, you're only getting the first quadrant. So let me paste that in there for us. All right, so you're going to get that, just the first quadrant. So we have to use the reference angles to help us. We can't just look it up on our unit circle and then find our x, y, and r. We need to use our reference angles. So for number 11, let's find our reference angle. So I don't know where 9 pi over 4 is on my unit circle, so let's convert it. I'm going to multiply by 180 over pi. Pi's cancel. 4 goes into 180 45 times. So we have 45 times 9. 9 times 5 would be 45. 9 times 4 is 36, plus 4 would be 40, so 405. So this is 405 degrees. Now this is more than one time around our unit circle, so we don't have a formula that we can plug this into. How can we find a smaller version of this? Minus 360. So when we subtract 360, we get 45 degrees. 45 degrees is in which quadrant? Quadrant 1. So 45 degrees is going to be our reference angle. Here, it doesn't matter if you convert it back because the question's not asking us for the reference angle. It's asking us to evaluate the 6 trig functions. So we're going to use our reference angle and look at our first quadrant of the unit circle. So that's why it's important here to find the reference angle, because you know your reference angle is going to be acute and positive. So since it's less than 90, it's going to fall in that first quadrant there. So let's let's list our 6 trig functions. We've got sine, cosine, tangent, and our reciprocals, cosecant, secant, and cotangent. All right, so 45 degrees would be pi over 4, so we're looking here. So our point is going to be square root 2 over 2 and square root 2 over 2. All right, so sine, what do we need to look at? We look at what? Y over R, which here our R is just 1, so it's just Y. When you're dealing with the unit circle, R is just going to be 1. So it'd be Y over 1, which is just Y. So our Y is square root 2 over 2. Cosine, we're looking at the X, so that would be square root 2 over 2. Tangent is Y over X. So square root 2 over 2 over square root 2 over 2. When we keep change flip, what do we get? If I divide the same thing by itself, what is it? 1. Perfect. Now we can find our reciprocal function. So we get 2 over square root 2, which we have to rationalize. So 2 square root 2 over 2 simplifies to just square root 2. Here we have the same thing, 2 over square root 2. When we rationalize, we're going to get the same answer, square root 2. And then cotangent, when we flip tangent, would also be 1. Now the very last thing we have to do is check the signs. All students take calculus. What quadrant is 405 degrees in? Quadrant 1. What's positive in quadrant 1? Everything. All of them are positive. So these are all positive answers. I'm going to put a little plus sign just to show us. You don't have to put the plus sign, but just so we know that we checked our signs, everything is positive in the first quadrant. So the last thing you want to do for these questions is check your signs. Use your all students take calculus, figure out what's positive, what's negative. Any questions here? All right, let's do 12. So same thing. We want to find our reference angle. So we have negative 300 degrees. Let's find the positive coterminal version of that. Actually, we'll find our reference angle first, but I want to do 13 because I want to make sure we check the signs there. So how would we find a positive coterminal version of negative 300? Add 360. So we're dealing with 60 degrees. 60 degrees is in which quadrant? The first. So our reference angle is the same as our theta, which is 60 degrees. So here we're looking for all 6 trig functions of 60 degrees. Negative 300 degrees is in which quadrant? If I go negative 300 degrees, which quadrant am I in? The first quadrant. So what's positive in the first quadrant? Everything. All students take calculus. Everything is positive in the first quadrant. So all of our signs would be positive. Let's do 13. So here we want to convert it, find out what our angle is, and then we need to find our reference angle. So I'm going to multiply by 180 over pi. Pi's cancel. 6 goes into 180 30 times. So I'm going to do 13 times 3. This gives us 39. Tack on a 0 to that, so 390 degrees. What quadrant is 390 degrees in? Oh, they're all in one. That's annoying. Don't forget to check your signs, because on the test or on the quiz, they're not all going to be in one. But here, 390 degrees is in one. How would we find our reference angle? They're not all going to be in the first quadrant. You just find your reference angle. Because if our reference angle was 30, you can just use your 30 degrees on your first quadrant. Well, your reference angle is going to be acute and positive. So it's either going to be 30, 45, or 60. And we'll talk about the case where it's going to be not one of those. But I'll do that in a second. But yes, for these types of questions, your reference angle is going to be 30, 45, or 60. That's why we need to know all students take calculus. If it's not in the first quadrant, the sign just changes. So here, what's our reference angle? 30. Awesome. We subtract 360, we get 30. 30 is in quadrant 1, so our reference angle is 30. So we're looking at 30 here. So I'm going to find my 6 trig functions. Sine, cosine, tangent, cosecant, secant, cotangent. So the point that we're using now is square root 3 over 2 and 1/2. So sine, we look at what? X. Just kidding, y. Sine, we look at y. That'd be 1/2. Cosine, we look at x. So x is square root 3 over 2. Tangent is y over x. So 1/2 over square root 3 over 2. What would we need to do here? Keep, change, flip. Keep the top, change to multiplication, flip the bottom to 2 over square root 3. Be careful when you're doing the math here and simplifying. 2's cancel, so we're left with 1 over square root 3, but we do need to rationalize. So this gives us square root 3 over 3. Cosecant, we flip sign, so that would be 2 over 1, or just 2. Secant, we flip cosine, so 2 over square root 3 would be 2 square root 3 over 3 after we rationalize. And then cotangent, we flip tangent. I'm just going to flip the original and we'll keep change flip again. So square root 3 over 2 over 1/2. When we keep change flip, keep the top, change to multiplication, flip the bottom to 2 over 1. 2's cancel, we get square root 3. What quadrant did we say we were in here? What quadrant? What quadrant's 390 degrees in? Quadrant 1. So what's positive in quadrant 1? Everything. So all of our trig functions are going to be positive. So always, always, always check your signs. Here everything is positive. If we were in quadrant 2, then just sine and cosecant would be positive. Everything else would be negative. All right, let's do an extra practice one. Let's say this asks for these 6 trig functions of pi over 2. Does pi over 2 have a reference angle? Where is pi over 2? If we convert it, what do we get? Pi's cancel, 2 goes into 180, 90 times. Can I find the reference angle of 90? No. But we can still find our 6 trig functions. Again, you're not going to be given this part of the unit circle, so you need to know this. This is why we're practicing this. So 90 degrees is up here. So if I can draw my own little unit circle, draw my 4 points that fall on one of your axis, your y-axis or your x-axis, what would be the point up here? Our x would be 0. What's our y? 1. It's a unit circle. We just go 1 unit in each direction. What would be our point out here to the left? What's our x? We're going to the left, so -1. What's our y? 0. We stay at 0. What's our point down at the bottom here? 0, -1. And our point out to the right? +1, 0. Perfect. So 90 degrees would be where? Zero, 1. So the point that we're using here is 0, 1. So let's find our 6 trig functions. Sine, cosine, tangent, cosecant, secant, cotangent. So sine, we look at what value? The y. So our y is 1. Cosine, we look at the x. X would be 0. Tangent is y over x. So 1 over 0 would simplify to what? Undefined. Perfect. Cosecant, we flip sine. So that would be 1 over 1, which is 1. Secant, we flip cosine. So that would be 1 over 0. What does 1 over 0 simplify to? Undefined. And cotangent, we flip tangent. So that would be 0 over 1. What's 0 over 1? 0. So these would be our 6 trig functions. So make sure you know you're not given this part of the unit circle, so make sure you know what each axis is. If you know how a graph works and what direction is positive, what direction is negative, these are kind of common sense. One other thing that I know you guys know, but just to review for the quiz, sometimes it'll ask for a specific trig function and it won't give you SIN for sine. It'll spell it out for you. So just so we're not shocked by what we see on the quiz tomorrow. Sine stands for sine. Cosine stands for cosine. Tangent, so TAN stands for tangent. And then our reciprocal functions would be CSC stands for cosecant. SEC stands for secant. And COT stands for cotangent. So some of the question uses the words, not just the abbreviation of it. So just make sure you know this. I know you guys know this, but just look it over so you know it for sure.